Hi everybody. So today I'm going to be constructing a simple Bitcoin trading strategy with some Monte Carlo simulation involved. So what the point of this is going to be is to load the C program into Python so the model can run much faster than it would if it was just standalone Python. So yeah, let's get started on the C part. So I'm going to define a function called GBM for geometric Brownian motion, and it's going to take the arguments of S for the stock price, um, mu for the drift, volatility, IV, um, T, an integer of N, an integer of paths. Okay, so the first thing I'm going to do is I'm going to create a variable called price, set it equal to 0, and then return price. So now I'm going to do for int I equals 0, I is less than paths, plus I, and then here I'll define the initial stock price, which is equal to the inputted stock price at each iteration. And then I'm going to do for int j equals 0, j is less than n, plus j. So I need to define a variable called delta time dt, and that's going to equal t divided by cast double n. Let me add some space in there. Okay, so the formula is going to be the stock price plus equals the mu times the stock price times dt plus the volatility times the stock price times dwt. And this is where we're going to include we're going to make use of the random number function. So I'm going to first define the seed up here. So I'll do srand time null. And then let me move this down here for now. So I'll come up here and do double dwt, and it's going to take an integer of num, and I'm going to set that equal to 10. So this is going to be double dw equals rand mod 2 times num plus 1. Let's mod that. Minus num divided by 100.0. So this is going to generate us a number between negative 10% and 10%. So then I'll just come here and return dw. Okay, so now we have this set. Down here we're going to do price plus equals the stock price at the end of the simulation. And then down here, price is going to equal e to the power of, so I guess no, we're not going to be discounting it. We're just going to take the average of it. So it's going to be price divided by equal double paths. And then it's going to return price. Okay, so we've got our geometric Brownian motion function now. We're going to come here and define a variable called lib, which equals c types ./simulate.so. So we do not have this file yet. We need to compile it. So we just have home.py and simulate.c. So this is how you compile it. First you do gcc minus shared minus o. I'm going to call this simulate.so. And then it's going to do simulate.c and then fpic. So it's compiling. Okay, so let's see if we have that file. Yep, we have simulate.so. Okay, so we're going to now define the arg types. So lib.gbm.arg_types equals c types of c double, that's the stock price, c types dot c double, that's the mu, c types dot c double, that's the implied volatility, c types dot c double, that's the time, and then we can just do int for the n and paths, so that'll be c types dot c int and ctypes.c int. Okay, so we got them all set. Now this will be lib.gbm.result restype equals ctypes.c double. Okay, I think we've got everything set. So now that we have this, let's do a practice run. So I'm going to do, I'll call it option, no, not option, sim price equals lib.gbm. So we need to define some parameters for this, but before we get to like importing them from the web, so that'll be s equals 100, mu equals 0.02, IV equals 0.344, T equals, so we're going to do this for 30 days, divided by 365.0, and N equals 1,000, and paths equals 100. Okay, so now let's key all these in, so it's going to be stock, mu, IV, time, N, and paths. And now print the simulated price. So to do that, I just have to reset the terminal and do python 3 home.py. Oh right, it's CDLL. My mistake. Okay, so it got us back a stock price of $99.76. Let's run this. So 118, 114, 116, 78. Okay, good. So it's running and it has good volatility in it. So now what I'm gonna do is I'm gonna take this out. I don't know. I don't really need them right now. So okay, everything's loaded here. What I'm gonna do now is I'm going to. We know the simulate function's working, so I'm just gonna close it for now. So we have to import. We have to fill the stock price, the mu, the risk. No. The volatility rate, time, and N and paths are set. So we just have to put these in. So what I'm gonna do now, I'm going to import the data. Let's start with mu, or I'll call it drift. Yeah, let's start with drift. So I'm gonna come here and do import requests, and then I'm going to do def crypto data ticker equals BTC USD. That's a given. So I'm gonna now come over to the API, and I have their candlesticks API here. So I'm gonna copy this, and I'm going to get second minute data. So that's granularity equal to 60. So I'll do URL equals this. So I'm going to add the format for the product ID, which is the ticker, and then granularity equals 60. So I'm going to get minute data. So this will be R equals, I also got to import JSON. So R equals requests dot get URL dot format ticker dot JSON. So now we need to take a look at the output of this, see how exactly we're going to get this data. So we get the highest, we get the most recent data first, I think. Let me just try this. Let's actually print it out. So I'll just do print R. So now I'll come down here and do crypto data, and then python 3 home.py. Okay, so we got the data in here. Let's just take a look at the timestamps. So this is 17163 3740, and this is 3800. Okay, so it goes from newest data to oldest data. So now I'm going to extract. So time, open, high, low, close. So that's 0, 1, 2, 3, 4. Um, so I'm extracting the fourth column. So that's going to be, I'll call it close equals numpy.array. Oh wait, let me also import numpy before I get too ahead with it. So that's going to be r dot transpose 4. So yeah, these are the close prices. So let's just print close. Okay, perfect. We've got the latest data at the first element. Okay, so in order to calculate drift, well, actually first let's extract the close price. So that's going to be current price equals close 0. And drift. So wait, we need the rate of return actually. So that's going to be close -1 divided by close 1 minus 1. And then drift is going to first be for R in ROR. It's going to be 1 plus R. And then this is going to be a product. And then subtract 1. So we got the drift. So let me think, am I missing something? So we got the, let me just come down here. So we got the stock price and we got the drift. Now we need the volatility and time, and that's going to come with the options chain. So I'm going to come here and return current price and drift. So it'll be S drift equals crypto data. So now let's get the volatility and time. So for that, I'm going to come to the Deribit documentation. So Deribit has a little bit different way of like importing data. They do it through socket now, and actually this doesn't work. And I'm going to show you guys how I'm going to have to like change this for it to work. So I'm going to copy this. Yeah, I'm going to copy this, and then I'm going to come here, and I'm going to put all of this code into this. So I'm going to call this options chain. Okay, so this is the message that we're going to be sending to the server, but I'm going to make some modifications to it in a minute. So this has to be in a tab. And yeah, so yeah, we're looking for Bitcoin. We're going to set the count equal to 500, and then kind option, and then so we pass in the message through the async IO. I'm just going to return this. So that'll be dump message. So I need to make some modifications to this though. So the first thing I'm going to do is I'm going to actually come down here and do async with, I don't need WebSockets, I need to define AIO HTTP. And we already have JSON. I might as well just put these up here. So yeah, it's probably better to put these up here. But yeah, so we got the message. So async with AIO HTTP dot client session connector equals AIO HTTP dot TCP connector SSL equals false as session. Okay, so it'll be async with session dot WebSocket connect WSS test.deribit.com/WebSocket/API/v2. as connection. So now we're going to come here and do await connection.send JSON. Wait, is it already dumped? Yeah, it's already dumped, so it's going to be message, and then it's going to be response equals await connection dot receive. Oh wait, this is actually send underscore str, and then response is await connection dot receive. So we're gonna return JSON dot loads response. So I'll call this well, actually, let me go ahead and print it out. So I'm going to come here and do print options chain. So let me reset this. Actually, as a matter of fact, let me make this a little bit bigger for now. We're going to make it smaller later. So I'm going to do Python 3 home.py. WebSockets was not defined. Oh wow, I actually forgot to even delete this code. My bad. Shouldn't have done that. So now let me reset this. Oh right, it's actually supposed to be response.data because we're using a different one. Okay, so reset that. Okay, perfect. So we have the options chain. Now the next step to do this, so we go into result, then we go to trades, and then it gives us all the options. So now I'm going to import pandas, and we're going to create a data frame. So import pandas as PD. So the first thing I need to do is I'm not going to return this. I'm going to do response equals this because we're going to do more in here. So I'm going to do response equals response result trades, and then for I in response, we're going to print I of instrument name, I of is it, hang on, IV price. Okay, I found price. And then I of IV. So I believe these are all we need from this. So it's going to be reset, and then I'll do Python 3 home.py. Okay, perfect. So we have all of these, but now comes the difficult part. We have to actually calculate the timestamp off of this date for this in order for this to work. So that's going to also require importing time and importing date time. Okay, so I've got my options chain in there. I'm going to create a function within a function. So I'll call this def fix name, and it takes an argument of u. And then so I'm going to split this now. So it's going to be s equals u dot split by the hyphen. So we'll do the strike. We'll do well actually no, we probably have to extract all of these. They're all going to be put in the same data frame. So it will just be I don't need the first column that says BTC. I need the date and I need the strike. Okay, so I'll do side equals S -1. So that'll be call or put. Or actually, I'll just call it op type. And then or rather, we'll just do call options for this. Forget the put options. But we need the strike equal to C, S of -2. So I'll call it the date equals S of 1. So now I need to create a dictionary here, and I'll call it so call it reference equals. So we need to put the month. So Jan is going to be 01, Feb is going to be 02. Okay, so we've got all the dates loaded. So now I'm going to divide the day up into. So let's start off with the year. So the year is going to be the date -2 to the end of it. So this portion, and it is also going to include 20. So this will just for. Let me just also make this a string, and then so the month is going to equal the date of -2 to -5, and day is going to equal the date -5 to the first element. So if the length of day is less than 2, day is going to be plus. Day is going to equal 0 plus day. Okay, so now we can do the date equals f string of month, day. Oh wait, I don't need these quotes in here. So day and then year. Okay, so now that we have the new date string, we are going to return the. So we just need the strike and the date. So strike. Well, actually, I don't think we need the strike for this. Yeah, because we're aggregating the volatilities anyway, so yeah, we don't need strike. It's just going to be the date. But month equals reference month. Yeah, okay, so we got that set. Now, so it's called fixed name. So this will be, I'll create a new data frame up here. I'll call it df equals this, and then that function is called fixed name. So it'll be fixed name of the instrument, and then I will do df.append, put these all as an array, and I need to divide the implied volatility by 100 as well. So everything's loaded in, and then it's going to be return pd.data frame of df and columns equals date, price, and IV. Okay, so now that we've got all that, let's print it out. So It'll be reset. Okay, so we've got the option prices. Now I want to pick a date. I only want options that are expiring on, what's the date today? 21st. I'll go for the 31st. So I'll come here and do df equals options chain, and then I'll do df equals, or no, I'll call it something else. Data equals df of df date equal to, so I'll input the date, so input date equals 05/31/2024. So it'll be equal to input date, and now print out data. So reset this, come down here, and we have it. So now we want to compute the aggregated implied volatility for these options, which are all expiring at the same time. So that will be, so yeah, now we're solving for V, and we're also getting T. Um, Actually, it'll be a good idea to go ahead and do T first. So I'm going to come here, and I could do, so I'll define CT, and I'll just include an argument of input date, so I'll call it iDate. And now we will do tx equals int time dot time. So it'll be t v equals time dot mk time, date time dot strp time, iDate. So the format is month, day, year. Dot time tuple. So now I'll return the delta, so that'll be tv minus tx divided by 60 converts to minutes, 60 converts to hours, 24 converts to days, 365 converts to years, because Bitcoin options are not like regular options. They trade like 24/7. So we got CT. Now I will define, so I will do T equals CT of input date. And before, let me just print out what T looks like. So print T. Let's just see what it looks like. So, okay, perfect. We got the right amount of time. So now we have solved for S, drift, and T, and we're about to solve for V. So that is going to equal total price is going to equal data price dot sum. And now weights are going to equal data price divided by total price. And let me just make sure I'm doing it right. So print weights. Okay, perfect. So now we could, so we got the weights for it. So the next step is to do IV equals weights dot transpose dot data IV. So let's see what the IV is. Okay, so we got the aggregated implied volatility for the options which expire on the 31st. So now we have all of our variables. Well, actually, we can make n and paths something different. So that'll be, so n equals to 1,500, and paths equals to, I'll do 100. So now we could pass all of the arguments. So let me just lower this down. reset that, and then so it'll be simulated price equals lib.gbm, and it is with the stock, drift, volatility, time, n, and paths. So now let's come over here and open simulate again. Yeah, stock, drift, implied volatility, time, n, and paths. So we got that set. And then now we are going to print so we're going to do if the stock, if Bitcoin's price is less than its simulated price, print buy Bitcoin. If simulated price is less than, greater than or equal to, if the stock price is greater than the simulated price, we're going to print sell Bitcoin. And actually, I'm going to print out their parameters too. So I'm going to print S, I hate that message, drift, IV, and time. And we're going to print S, drift, IV, and time. Oh, it's big T, not little t. Okay, so let's see what the result of this is. So it's going to be Python 3. Oh wait, I should also put in the simulated price as well. So simulated price, Python 3 home.py. So it's saying sell Bitcoin, so it generated a price that's much less than what Bitcoin's price is. So just go ahead and refresh it. Oh, this one's even less. This one's saying buy Bitcoin because it got a higher price than what it's at. So yeah, it's of course the simulation is not going to be right all the time. Before I go though, let me increase this power of the simulation. So I will do 10,500, and I will do 1,000 paths. So this may take a little while, but let's see if this will pull through. So no way, it ran that fast. Holy shit. Let's keep running it. 409. Okay, so now you guys can see, like, if you're ever doing a Monte Carlo simulation, you don't want to make the path too long, or it's going to generate you some, like, crazy prices, like 15,000 iterated over 1,000 times. Okay, here it got the price close. So maybe that's what the thing I should do is, like, make sure it only returns if it's, like, a close price. Well, no, we can't do that because you're not, like, you can't ever anticipate that a price that's closer is going to, like, stay that way. But overall, let's keep running this to see which tells us more. So far we got 2 buy Bitcoins, we got 1 sell Bitcoin. Let's see what this says. So this says sell Bitcoin, so it's 2 and 2. Sell Bitcoin, 3 and 2. Buy Bitcoin, 3, 3. Sell Bitcoin, 4, 3. Sell Bitcoin 5.3. Okay, so yeah, let's just be like, we should go short end this, and I want you guys to check the current price at this simulation is $70,201.71. So let's put a stamp on that and let's check and see whether this short prediction was right on this algorithm. But yeah, I thank y'all for watching this video, and I love it. Like, I'm glad I learned how to, like, import, like, a C function into Python. It's really good. But yeah, peace out.